This measurement marks an important step towards achieving the scientific goals of next generation of neutrino experiments, namely, the Deep Underground Neutrino Experiment, DUNE. Neutrinos are tiny subatomic particles that are both famously elusive and tremendously abundant. While they endlessly bombard every inch of Earth's surface at nearly the speed of light, neutrinos can travel through a light-year's worth of lead without ever disturbing a single atom. Understanding these mysterious particles could unlock some of the biggest secrets of the universe. Our ultimate goal is to study the properties of neutrinos, but first we need to better understand how neutrinos interact with the material in a detector, such as argon atoms. One of the most important neutrino properties that DUNE will investigate is how the particles oscillate between three distant. Scientists know that these oscillations depend on neutrinos' energy, among other parameters, but that energy is very challenging to estimate. Determining the detailed energy-dependent cross-sections provides physicists with an essential piece of information to study neutrino oscillations. Once we know the cross-section, we can reverse the calculation to determine the average neutrino energy, flavor, and oscillation properties from a large number of interactions, said Brookhaven Lab postdoc Wenchang Jiyu, who led the physics analysis. To accomplish this, the team developed a new technique to extract the detailed energy-dependent cross-section. For example, if you are studying a muon neutrino, you generally see a charged muon coming out of the particle interaction, and this charged muon has well-defined properties like its angle and energy. So, one can measure the cross-section as a function of the muon angle or energy. But without a model that can accurately account for missing energy, a term we use to describe additional energy in the neutrino interactions that can't be attributed to the reconstructed variables, this technique would require experiments to act conservatively. The research team led by Brookhaven. To do so, the team applied their expertise and lessons learned from previous work on the MicroBooNE experiment, such as their efforts in reconstructing interactions with different neutrino flavors. We added a new constraint to significantly improve the mathematical modeling of neutrino energy reconstruction, said Louisiana State University Assistant Professor Hanyu Wei, previously a Goldhaber Fellow at Brookhaven. The current measurement was done in one dimension, but future research will tackle the value in multiple dimensions, that is, as a function of multiple variables, and explore more avenues of underlying physics. This work was supported by the DOE Office of Science. Make a Difference. Sponsored Opportunity StorySource. Materials provided by DOE, Brookhaven National Laboratory. Note: content may be edited for style and length. Book: L. Camilleri, D. Caratelli, I. Caro Terrazas, F. Cavana, G. Cerati, Y. Chen, D. Chanchi, J. M. Conrad, M. Convery, L. Cooper Trendle, J. I. Crespo Anadin, M. Del Tutto, S. R. Dennis, P. Detje, A. DeWitt, R. Dyerba, R. Dorrell, K. Duffy, S. Deitman, B. Eberly, A. Hereditato, J. J. Evans, R. Mills, K. Mystery, A. Mogan, T. Mohai, J. Moon, M. Mooney, A. F. Moore, C. D. Moore, L. Mora Lapin, J. Musso, M. Murphy, D. Naples, A. Navar Agassiz, M. Nabat Guinot, R. K. Neely, D. A. Newmark, J. Novak, M. Nunes, O. Palomara, V. Paulone, A. Papadopoulou, V. Papavasiliou, S. F. Pate, N. Patel, A. Poudel, Z. Pavlovich, E. Piasecki. Rice, L. Rochester, J. Rodriguez Rondon, M. Rosenberg, M. Ross Lonergan, G. Scanavini, D. W. Schmitz, A. Shuckraft, W. Seligman, M. H. Shavitz, R. Sharankova, J. Shi, J. Sinclair, A. Smith, E. L. Snyder, M. Soderberg, S. Soldner Rembold, P. Spencerus, J. Spitz, M. Stankari, J. St. John, T. Street. First measurement of energy-dependent inclusive muon neutrino charged current cross-sections on argon with the MicroBooNE detector. Physical Review Letters, 2022. 128, 15, doi. 10. 1103, Phys Rev Let. 128, 151801. Cite this page. DOE, Brookhaven National Laboratory. 2022, April 12. Breakthrough measurement elucidates neutrino interactions. Science Daily. Retrieved April 12, 2022 from ift.tt/mcubagw DOE, Brookhaven National Laboratory. Thanks for watching. Please subscribe my channel for more videos.